Hey folks, this is Kevin Jones here to talk to you about how we represent strings or strings of characters in the LC3. So our objectives today are to refresh our memory on ASCII encoding and to be able to convert English letters and the numbers 0 to 9 into binary values and back again. And then to describe the purpose of something that's called the null terminator that helps us differentiate a string in memory from other things in memory. So let's get started. Okay, so here's how I might use a string in the LC3. I'm creating a zero terminated string. I'm going to load the first value to R0 and then call my trap instruction, which we'll talk about in a slightly future lesson to be able to print that to the console. So the question becomes, okay, how does the LC3 know what to do? And part of the problem, if you imagine that I've got some memory here, part of the problem comes from the fact that these values, they're just zeros and ones. So how does the LC3 know what's data, what's instructions, what's a message, and how do we get letters in here? So the key to that second part, to convert these letters into numbers, is using ASCII, which stands for the American something code for information interchange. But this is it's just a means of encoding values. So the value capital N is encoded with the binary value or the hexadecimal value 4E in ASCII. And so I reprinted the ASCII chart down here as a means of reference. You can see here capital N has the hexadecimal value 4E. And so we can use ASCII to convert each of these letters and even this exclamation mark into an actual binary value and then store those in sequential memory locations. And so ASCII helps us convert the letters into actual binary values. There's nothing really inherently that's says 004E is capital N as opposed to an actual decimal 78. Except the fact that when I'm writing my assembly code, I'm using the output instruction, and by giving it the first value memory, we're sort of assuming that it is an ASCII character. Now, to solve the first problem mentioned about how do I separate this thing in memory, there's if my display routine is reading values and trying to display them to a screen, there's no telling where it needs to stop. So these whenever we store a message in memory, we always finish it with the literal value 0. It's what we call the null or the zero terminator. And so as when we are operating on this message, this string, and starting at the first location, which has that first ASCII value, we can continue going until we get to a 0 value, and that's what sort of marks the end of the string. And you can see here that 0 is reserved in ASCII for the null character, the null terminator. And so in memory, this message will always take as many spots in memory as there are characters, plus one more for the null terminator. One last thing I want to share with you about the ASCII chart that's kind of cool is that it was laid out with some, somewhat intentionally. You'll notice here that the capital letters are all offset from the lowercase letters by the same amount, specifically decimal 32. So capital A is 65 in decimal, and lowercase a is 97. And it goes that from A to Z. So this can be a handy way to convert sort of from uppercase to lowercase. If I want to go from uppercase to lowercase, all I have to do is take the ASCII value and add 32 or add hex 20. If I want to go from lowercase to uppercase, all I need to do is subtract that same amount. And then similarly, the digits 0 to 9 are all offset by a value of hex 30, which is kind of convenient. So if I've got an actual integer, a numeral that I want to convert into its ASCII character, all I need to do is add hex 30 or add a 48. And if I want to try to convert a single digit in ASCII back to the integer form, all I need to do is subtract the same amount, subtract 48 or subtract hex 30. Okay, so that's how we encode strings in the LC3. We can use the string Z assembler directive to create it. And what that actually does in memory is convert these letters and symbols into ASCII codes followed by a 0, which helps the LC3 figure out where in memory it needs to stop when it's reading this message. All right, that's all I got, folks. See you next time.